All right, chapter 3, day 7. This will be good. I start off with slipping in something about Simpson's paradox. This is not an AP standard. I just enjoy it. I am not going to cover this. It's not tested, so don't worry about it. It's something I would do live for fun, and I have other examples. So let's just go down to this, practicing a couple of questions. These are going to be good. One is using a calculator, and one is using like a table that they would give you on a test. One is very realistic. So this is going to be really good. All right. So McDonald's beef sandwiches, carbs and fat. We want to see if they're related. Okay. So I put carbs in L1 and fat in L2. I mean, really, you could probably switch those because I don't know which one would be X or Y really, but I didn't. I left. I just did it the way it was labeled. Remember, correlation doesn't care if you switch them or not. It doesn't make any difference. We've gone over that in subsequent lessons. So, pause here to type it in your calculator. But when you're done here, you're going to go, I'm going to go second quit. I'm going to go stat calc 8 for L1 and L2. And remember, on your calculator, it might be L1 comma L2. They're also different. I mean, from the TI family, I should say. All right. So here's that. All right, so that is the A and B. I switched it around a little bit, so I have A back here, but you can do either way. So the negative 40 is not realistic at all. We'll talk about that in a second. So I'm going to hit on a few cool things on this one, so that you're going to like this. All right, so calculate it. Make sure you do the scatter plot. Or I'll do the scatter plot too. So I'm going to go second y equals. I think I got it all set up. I'll go zoom 9. Should work. Yeah, there's the scatter plot. And I'm going to go ahead and put the formula in there. So 1.713x minus, I can do minus there, 40.2. Okay, I'll put graphs. Yeah, so there's the line. Looks pretty good, right? I mean, you can tell it's more or less linear. The residual plot would be randomly scattered if you can visualize that on its side there are 4 points above the line and 5 points below. That's pretty balanced. You can't get 9 any better than that. So when you label that, you have to label y hat. Y hat is predicted fat. Make sure you put the word predicted, because that's part of it. It's not just fat, it's predicted fat. And X is carbs. Okay, got that? Interpret the slope and the Y-intercept. This is good. So the slope is right here. And if you remember, that starts with for every as your sentence frame. For every gram of carb every gram of carb or carb gram, the predicted amount of fat increases by 1.713 grams. Very good. The Y-intercept's a good one. This is literally what it says. If a burger contained 0 grams of carbs, put 0 in for this, right? The predicted fat content would be negative 40.2. I didn't write this, but that is an example of extrapolation. And this is impossible, and this is unrealistic. 0 is not part of the domain of study. If you look closely, the domain of study was between 31 and 45. So if you get really far away from that, and 0 is really far away from that, it's not going to be realistic. And that's what happens here. This is an example of extrapolation. That's literally what it means. But I would follow up with, this is an example of extrapolation because that's impossible. In this case, it's impossible. Other times, it's just extrapolation because it's just too far away from the domain of study. I really like that term, domain of study. That's kind of cool. All right, so let's slide down here a little bit. Calculate and interpret the residual for a Big Mac with 45 grams of carbs and 29 grams of fat. I've seen this question, calculate and interpret the residual. All right. So first of all, let's try to figure out where this is. Okay. So 45 grams of carbs is the highest one. All right. So that's the one. That's the one out here. 45 grams of carbs. And if you look closely, it appears to have a negative residual. So I'm kind of walking you through this here. It's that point right there. I know that because 45 is the farthest one over if you look at the charts. Okay. So that is a negative residual. Okay. It's I don't know what it is. I can calculate it very easy. So what you have to do first is you got to put in 45 into the equation. Okay, so I'll write that here. So I'm going to go 1.713 times 45 minus 40.2. Okay, I'm going to put that in, and I'm going to go over here and calculate that on the calculator. All right. Second quit. So I'm going to go 1.713 times 45 minus 40.2. And I get 36.885, which of course I have right here in my notes. All right. So if you recall, the residual is y minus y hat. It's the actual, which is 29, minus the predicted, which is 36.885. And of course, if you do that, you're going to get a negative residual. And we knew it was negative because if you recall, I'll go back to the drawing here. If you recall, that point right there where my cursor is it's below the line, so it's negative. Remember, a negative residual means the line over predicted it. Okay, so interpretation. Now I'm going to say this, and you probably want to write this down. It's pretty simple. The line over predicted this point by 7.885 grams. The line over predicted this point by 7.885 grams. A negative residual means an over prediction by the line. A positive residual means an under prediction by the line because the line is under the point on that. Okay. Those are some cool little questions that can pop up. Okay. I don't think I need the computer for the next one or the calculator for the next set. Let's go down to this. This is kind of fun. I remember doing this in like junior high science or something. We put Mentos in a bottle of Diet Coke and the carbon dioxide released. If I'm in class, I usually show you what I'm talking about so you understand what I'm talking about. I don't like blow anything up, but just kind of cool to do. Okay. And then I had this whole prompt with a couple of students from my past, Bat and Juanita. They were actually in my class, 2003 or something. Okay, using 16-ounce bottles of Diet Coke, they had to drop 2, 3, 4, or 5 Mentos into a bottle, wait for it to fizzle down, and measure what was remaining. Okay, so as you can see, they did 2 Mentos 3 times, 3 Mentos 4 times, 4 Mentos 3 times, and 5 Mentos 4 times. It makes a general trend. Okay, a general linear trend. I mean, it's not perfectly linear because there's not a lot of variety, but it's pretty good though. Okay, so this is really common, this setup. And so this is why we want to really focus on this, okay? This is so common. They usually don't have you in this section actually calculate things because they don't want you to be messing with the calculator too much. And they also realize not everyone has one, so they want to be fair. So when you do this, this is A, okay? And this is B, where it says coefficient A and B. This standard error of the coefficients will be studied later. This will be studied in chapter, I think it's 12. Chapter 12, we'll study that. We'll actually review this entire chapter in chapter 12, which is really nice, okay? And the t-score and the p-value, we will also study all in chapter 12, okay? So you got to know A and B. You got to know this is R squared. Remember, R squared is always positive because it's the number that's been squared. If you want R and you square root it, check to make sure if it's positive or negative by either seeing the direction of the line being positive or negative, or check the slope because it'll be the same as the slope. And this S is that thing we've been talking about a long time. Okay. All right. So let's do this. What is the equation of the least squares regression line? Define any variables you use. That's pretty easy. So I wrote it out for you, and you have to define the variables. Y hat is predicted, remember, amount of coke expelled, and X is number of Mentos used or dropped. Okay. Interpret the slope. We've done this a lot. Here's the slope right here. It's a for everything. For every Mento used or dropped, the predicted amount of Diet Coke expelled is 0.0708 cups. You gotta get the unit on this. It's cups. What is the correlation? That's kind of a bad question. What I mean is, I should have said what's the value of the corporate correlation, and interpret is really what I should have said. Sorry about that. Okay. So R, what you got to do is you got to square root R. And when you square root it, you gotta make a decision. Is it positive or negative? This is a positive slope up here. You can see it's going upwards, so it's positive, and it's also the slope is positive, literally. So it's going to be a positive number. So if you square root 0.602, remember to square root, and I'll do that for you real quick. Let's make sure we got this. Clear the drawings there. Make sure you square root. Let's see if I can quit. Second square root 0.602. Don't do 60.2. Okay. Whoops. Try that again. 0.602. Okay. There we go. Some people accidentally will square root 60.2 because that's what it says in it's squared, right? But R is a decimal, so you got to change that percentage 60.2 to 0.602. So there's a little tip too, where 3 or 4 of you will do that unless I told you that. All right, so 0.7758. Great. You can just go 0.77 on it if you want. So there is remember the 3 words: moderate, positive, and linear. Remember, it's strong, mild, weak. So strong is 0.8 to 1, or if it's negative, negative 0.8 to negative 1. Moderate, 0.6 to 0.8. Or for the negative one, negative 0.6 to negative 0.8. Okay, and then mild is in between 0.6 and negative 0.6. There's a positive linear relationship between the number of Mentos used dropped and the amount of Diet Coke expelled. Okay, is the linear model appropriate? All right. There's 3 things you should look at for this. Okay, one is the residual plot right here. You want that to be randomly scattered, and indeed it is. 2, you want to just check the eyeball test. Does that look roughly linear? Yes. And 3, you kind of want an R squared value that's fairly high. 60% or higher is pretty good. Okay. So I just put the first thing, but you could definitely put other things. Yes, the residual plot is randomly scattered, and I might put and. It looks the data looks linear, and R squared is relatively high. That would be a great answer. Okay. Would you be willing to use the linear model to predict the amount of Diet Coke expelled when 10 Mentos are used? All right, 10. We studied 2 through 5. Would you predict with 6? Maybe. With 1 on the other end, maybe. But 10? 10 seems a little bit far from the domain of study, and maybe the trend stops being linear and turns exponential or does something else very strange. So I'm going to say no. This would be a case of extrapolation. Let me underline where I'm at. Extrapolation. Our linear model is reliable up to only 5 Mentos. That's a good answer. Okay. Calculate and interpret the residual. I'm on F. For a bottle of Diet Coke that had 2 Mentos and lost 1.25 cups. Okay, bottle of Diet Coke that had 2 Mentos and lost 1.25 cups. Okay, 2 Mentos and lost 1.25. All right, so here we go. So I'm going to put 2 into the prediction model. Okay, so here we go. It's right here. I put 2 right in there. Okay, and if you multiply that out, you get this. Okay, that is y hat. Remember, the residual is y minus y hat. So I go to here, put the y from the prompt, the actual, subtract the residual, and you get 0.1064. Okay, so there's a couple of ways to interpret that. You could say the amount expelled was 0.1064 cups more than we predicted, or you could say our model underestimated the amount expelled by 1.1064. Either way, because that point is going to be above the line. Okay. All right. Interpret the values of r squared and s. This is a good one. Okay. So r squared, and again, this is off the chart. You can see it right there, s and r squared, and I'll circle them for you. They're always in the same spot, s and r squared. Okay, so I wrote those down below. Okay, r squared is, so 60 point, this is a sentence frame, which is in the early days of this chapter. 60.2% of the variability of Diet Coke expelled is due to the amount of Mentos used or dropped. 60.2% of the variability of Diet Coke expelled is due to the amount of Mentos used or dropped. Okay, and then this S is really simple. It's how far off the typical prediction is. It's kind of like an absolute value problem. So let me just kind of generally look at it with you, okay? So if you're looking at these, at this chart, let's look at the residuals, okay? So this is how far off they are. This one's off by 0.1. This is off by a really small amount, negative 0.02 or something. This is off by negative 0.1. What they, the formula isn't exactly this, but it's kind of the average absolute value. So take all these values and then add them up in absolute value form and get an average. That's more or less what it is. See where it says 0.06? So they're saying the average residual is somewhere in here, 0.06, right? On the positive or negative side. Isn't that kind of what it appears the average is? Okay, that's all it is the average residual. Okay, so I'll word it a little bit differently. I'll say, and let me get where I'm at here. The typical difference between the amount of Coke expelled and the mean amount of Coke expelled is wait, I had the wrong number there. What did I do wrong there? I got the wrong number there. Hold on, everybody. It's 0.06. Sorry about that. Okay, so I'm going to scratch this out. I don't like when mistakes happen, but we're going to roll with this. Okay, so I'm going to write it right here. So it's about 0.06. The typical, my face here, typical prediction is off by 0.06 cups. Okay, hope that made sense. Sorry about this. No. Okay, all right. Last one. If the amount expelled was measured in ounces instead of cups, how would the value of R squared be effective? Remember, if you change units in R and R squared, or you add or subtract something in a systematic way, R and R squared won't change. It doesn't matter by the units. R is unitless. Okay. Now S would change if you go from ounces cups to ounces. It's a scale of 8. Okay. You'd have to multiply S by 8 to get a new unit, because S has a unit. S is in cups. R squared is unitless, so is R, so they won't make any difference. Okay, I hope that was cool for you. I think that's a really, really good day to sort of get it all kind of dialed in. All right. Thank you very much.